Yesterday, due to time constraint, I have not been able to derive the formula dy dx as dy dt divided by dx dt. As I mentioned yesterday, if you have a curve like this, in general, you can describe the curve by making a set of parameterizations to describe how the positions of x and y be described in terms of a set of parametric equation. So here we let x to be, say, some function of u, and y to be another function called v. So v and u are two sets of equations, a set of two equations that parameterize the curve, and the coordinate is changing with respect to the values of t, where t is to be some kind of interval starting from somewhere to somewhere, right? So the intervals is a number from some number to some number. So I'll just write I to represent the interval in which the parameter t can take. So you can ask the questions of what is the curve on the point P. And at this point, the coordinate is x and y, and you want to ask what is the derivative of the curve. So the derivative at the point P, namely the slope at this point P. So the coordinate of x and y, they are governed by a set of parametric equation, u and v. So how do you derive this formula? dy dx equals to dv dt over dx dt. So to understand that, you just try to zoom in to this particular area and you zoom out. So within these particular intervals of P, you can imagine that the P is like this. Then in these particular intervals, the curve will be like this. So in this sense, the values of the coordinate y could then be understood to be given by the functions acting on the values of x. Here, y and x are the coordinate of the point P. So here, f is n functions that describe this curve. So you can write this y equals to fx as f acting on the values of x, where x instead is actually given by the function of u of t. So you express x as though it is in terms of the parametric equations of ut. So here you can also view the coordinate of y in terms of the function v. Right? So since y is given by vt in terms of the parametric equations, so I would then write y as f composed of u, and this is a function of t. Okay, so here let me begin again my argument. I am considering a point sitting on a generic curve P with coordinate x and y, and these x and y coordinates are described by a set of parametric equations u and v in terms of the parameter t. So I zoom into this particular area that contains the point P, and within this small box, if the box is chosen appropriately, then you can approximate or you can express this part of the curve within the box that contains the point P to be described by a function of f. where f is a function that relates the coordinate y and coordinate x. And with this assumption, the coordinate of y and x are related to this function of f. So since we assume x and y are parameterized in terms of t through equations u and v, then the values of x is then can be expressed as u of t. So you have y value, which is the coordinate, equals to the values of the x coordinate, which is given by u, the parameter t, as an input to the function of f. So you look at this one, then you know that y equals to f acting on the input of u of t can then be expressed as an composite function comprised of f and u. So now you can see that the coordinate of y is a function of t. So you ask this very simple question. Let us take the derivative of y with respect to t on the left-hand side. And we have actually been talking about these equations in the chain rule. So in the chain rule, we are saying that if you have an composite function, then you can use this formula. The composite function says if you have a function of a function, like this one, let me try to dig out the formula for the composite functions. Okay, so this is the formula for the composite function. It means that if you have a function of made up of f composed of g, if you have a function of f composed of g, then the derivative of this composite function. So I'm going to replace this x by t. So the derivative of this function by the chain rule says this is equal to df du times du dt, where here the u is just your g. Okay, u in terms of t is u in terms of t is just your gt. So this is the chain rule that the composite function f composed of g, the derivative of it is just the product of df, du, dt, where here the u is just your g. So by making use of this composite function, then you can easily write this down to be equals to df, du times du, dt. Okay, so f here is the function of y. So you can identify f as y and u to be identified as x. So here I'm replacing f by y, u by x. So here you then have dy, dx, dx, dt. Okay, so dy, dt is then given by this relationship, which is a relationship that relates the dy dx of the point P on the parametric curve. And dy dt, dx dt is just the time derivative or the t derivative of the coordinate x and y in terms of u and v. So you are always given a set of parametric equation, x equals to u, v, ut, y equals to vt. So with the knowledge of how y and x depend on t, you can then obtain the derivative of y and x with respect to t. So with this and this, then you can calculate the dy dx that represents the slope of the tangent line that is touching the point. So that is how we arrive at this formula, not this formula, arrive at
Kasi aku tengok Griezmann punya apa? Tak, dia tak ada assist, tak ada gol. Tapi tak tahu lah, dia macam
okay, so that is how we arrive at the formula for dy dx. I'm sorry about my technical error. There is a difficulty for me to call out the windows for my PowerPoint. So for the last few 20 minutes or so, I was trying to explain how to derive this formula. Right. So the formula you can easily memorize, but it would be best if you can explain how this formula comes about by using the argument that I prepared in these two slides. In the exam, of course, most of the time you will not be asked to derive this formula. Like usually people just memorize the formula. However, I strongly encourage you to try to explain to yourself how a formula given to you can be explained and can be derived. If you can explain and derive the formula yourself without rote memory, without memorizing it, that means you are learning. If you are not, you just memorize it, but without knowing how this formula comes about, you are not really learning. You are only memorizing. Okay. Okay, so that is what I want to tell you about the derivations of this formula. So let us go to the next bit on how to do the implicit parameterization.